So one method for solving a system of linear equations with two equations and two unknowns, which is what I have here. I have two equations and I'm numbering them 1 and 2. And we have two unknowns, x and y. And one method for solving them is to use the elimination method. The elimination method involves us eliminating one of the variables, so either the x's or the y's, from the system of linear equations, either by addition or by subtraction. So let's take a look at some examples of how that can be done. Think about the coefficients on x and the coefficients on y. If you take a look at the coefficients on x, we have a 2x in the first equation and a 3 is the coefficient in the second equation. Now, if you look at the coefficients of y, we have a +1, because you don't see the 1 there, but that's a 1. And we have a -1. Now, if we want to eliminate those by either addition or subtraction, think about addition. If I do +1 and I add, that's the addition method, and I add a -1, what number do I get? Well, +1 plus -1 is the same as +1 subtract 1, which is 0. And this is what we're aiming for with the elimination method. So we want to have matching coefficients, 1 and 1, with opposite signs if we're going to use addition. So let's take a look at that. If we add these vertically, because we have to add like terms anyway, all right? So these are like terms right here. If I were to add those, 2x plus 3x, that is 5x. And we're going to add some other like terms, which are right here. Oh, and I was going to do that in red. Just a moment. We're going to add those two, which are like terms, 1y plus -1y. So that is 0y equals, and notice I have these all lined up, like terms and so on. Now we have the constants on the right side of the equal sign. Well, they're like terms as well. So let's add them. 9 plus 16 is 25. Oh, 25. Okay, so this makes the equation a lot simpler because this doesn't really mean anything here. So we have 5x equals 25. Notice that we have eliminated one of the variables. In this case, it was the y's that we eliminated. So now we can solve for x. X is equal to 25 divided by 5, which is 5. At this point, we have half of the answer because remember, the answer is a point xy, or a solution for x and a solution for y. Well, we've got half of the answer. So the other half of the answer can be found by substitute x equals 5 into either equation. That's one way. Or we could try to use the elimination method to eliminate the x's and solve for y. In this case, we don't have matching coefficients, so we would have to do something to make them match. And we can look at that in just a moment. Let's just solve using the substitution method first. So I'm going to take my x equals 5, and I'm going to sub x equals 5 into equation 1. It doesn't matter which one I put it into. So 2 times x, well, x is now 5, plus 1y equals 9. 10 plus y equals 9, y equals 9 minus 10, y equals -1. So the solution to the system of linear equations is 5 minus 1. Okay, now If you didn't want to use a substitution method, we'll need to take a look at how to eliminate the x terms and leave just y's. So let's do that. Now here we are with the equations rewritten again. Notice we do not have matching coefficients on the x's, but we can make them match because it is possible to multiply through an equation by a constant and not change the equation itself. So if I multiply this first equation by 3, and then I multiply the second equation by 2, notice that we will have the coefficients of 6x in both. So let's do that. The first equation is getting multiplied by 3. When we do that, we need to multiply every term by 3. So 2x times 3 is 6x. 1y times 3 is 3y. And 9 times 3 is 27. That's the first equation. These are equivalent equations. One is just beefed up in a sense, right? But the relationship between the variables x and y is the same. All right, well, for the second equation, we want the coefficient to be 6, so I need to multiply my 3 by 2. That means multiply each term in the equation by 2. So 3x times 2 is 6x, minus 1y times 2 is minus 2y, and 16 times 2 is 32. Now we have matching coefficients on the x's. Notice that they are the same sign. How are we going to get a 0 from this? Will we be doing addition or subtraction? What will zero these out? Think about that. If I add them, 6x plus 6x, I will get 12x. That's not going to eliminate it. We want 0x. If I do 6x subtract 6x, then we will get 0. So subtraction is the choice in this case, when the signs are matching. When we use subtraction to eliminate the x terms, we have to use subtraction all the way through. So I'm going to use subtraction vertically here. 6x subtract 6x is 0x. That's what I was going for. Check. Now we need to do the same thing for the other two. So watch the signs. This is a little bit tricky. Plus 3y subtract negative 2y. So that's plus 3y plus 2y is 5y plus 5y. And on the last one, put that up there, 27 subtract 32. Well, 27 subtract 32 is minus 5. We're doing blue here. So the equation is 5y equals minus 5, or y is equal to minus 5 over 5, which is minus 1. So in this way, we have also solved for y to be minus 1. Remembering from the first method, we got x was equal to 5, y equals minus 1. There is our solution. Here are a couple more equations. This is a system of linear equations, two equations with two unknowns again. And I would like you to think about the elimination method and see if you can solve, at least for the first variable, using the elimination method. Remember, we are looking for matching coefficients, either the same sign or different signs. And so we did addition if they were opposite signs, and we do subtraction if they're the same sign. That's how we produce the 0 and eliminate, okay? So pause the video and give this one a try. Well, I notice that I have matching coefficients on the x, and they are the same sign. So I need to use a subtraction method. I recommend big square brackets around the second equation to remind yourself that you are doing subtraction. So 1x subtract 1x is 0x. Minus 2y subtract positive 3y is minus 5y. And 14 subtract 9 is 5. So minus 5y equals 5, or y equals 5 over minus 5, which is minus 1. That's half of the answer. Now we will set up, and just for practice, we will do the elimination method and solve for the x variable. I'll get that set up. Okay, so we already eliminated the x variable. Now we need to eliminate the y variable using the elimination method. And remember, you don't have to use elimination twice. I'm just doing it again to show another example. You can use substitution once you have one of the answers. Okay, so noticing that we have different coefficients on the y. They are opposite signs. That's okay, but they're different values. How can we make them the same? We must multiply through equation 1 by some value. And basically, I remember you're multiplying by each other, right? So the 2's got to be multiplied by the 3. The 3 will then get multiplied by 2. So the first equation is times 3. I'm going to leave it negative. I'll tell you why in a moment. So 1x times 3 is 3x. Minus 2y times 3 is minus 6y. And 14 times 3 is 42. On the second equation, I need to have a matching coefficient on the y. So I must multiply through the whole equation by 2. 1x times 2 is 2x. 3y times 2 is 6y, and it's positive. And 9 times 2 is 18. Now, we have matching coefficients on the y's. So we can choose addition or subtraction. All right, so add or subtract. What do you choose? You want to choose the one that's going to produce a 0 after you do it on those two terms. That is right here, right? How will we get 0 from this? By adding them together or by subtracting? And minus 6y plus 6y is 0y. So we must choose addition in this case. And so it's okay. You can also use the big brackets and put your addition outside there. So 3x plus 2x is 5x. And 42 plus 18 equals 60. And now we just have the equation that 5x equals 60. X equals 60 over 5, which is equal to 12. So the solution is in the form of an xy point, right? A coordinate, an ordered pair. The solution is 12, and for the y, I believe we got minus 1. How could we tell if this actually works? We can tell it works by subbing it into both equations. This point, if it is the solution to the system of linear equations, if it is the single point where these two lines cross, then it will be the only point that satisfies both equations. So let's do that now in a check. So we're going to check the point 12 minus 1. And we'll put this into equation 1. Equation 1 is x minus 2y equals 14. So we should now sub in the value. So x is 12. I'm going to put a 12 there. Subtract 2 times y is minus 1. And that's the left side. The right side is equal to 14. Is 12 plus 2 equal to 14? Yes. All right, we got a big check. This point is a point on this line. Let me just move this over and we will do right beside here. Let's check equation 2. Equation 2 is x plus 3y equals 9. All right, x plus 3y equals 9. The left side, we must put in our 12 plus 3 times minus 1. The right side is equal to 9. 12 subtract 3 equals 9. Yes. Since this point satisfies both equations, it is the solution to the system of linear equations, and that's a check on that. Remember, when you are solving systems of linear equations using the elimination method, you should always make sure that you have your equations in the same form, lined up with like terms, okay? It really helps to be very organized with it. And if you don't have matching coefficients, then you can do something like this to make them match. You may have to do it to both equations, or you may only have to do it to one equation. Just make sure that when you multiply through, that you multiply each term by that number so that you don't change the relationship of the variables. And that's all. Thanks for watching.